Alright, so I'm Isaac Swift,
And I'm Adam Garouk.
and we designed the LTS 2000 racing system. So we kind of based this off a quote by Ricky Bobby, one of my lifelong
Movie actors quotes.
yeah. So if you're not first, you're last, and this is our advertisement here. Alright, so that was a little thing of what this small thing can accomplish. So we want to make an easy to use, affordable laser timing system. Need to be lightweight, simple, and self-contained. Need to be used for all types of lap timing, whether it's car racing, any singular thing. We can't do multiple, we can't have like two different things, 2 different times, but we can do just any singular thing going around a track we can do. So it should be capable of outputting signals for different lights. For instance, if you, for example, I don't know why you would, but if you had a stoplight laying around, we did, an old traffic stoplight, you can hook this up to our system and it should be able to work just fine. You may need to add a couple of relays to boost power, but that's what we want it to be. We want it to be customizable for anybody's needs. Simple controls should be available on the system, but many more options will be available on the integrated website.
And research. So we started out with research. These were the 2 that stuck out for us, and it's kind of the same similar thing. They wireless and they reflect. And this is $1,074, and that's just about $5,000. And we can build this for, what was it?
Like 50.
50 bucks.
So you can see that compared to this is a lot less cost difference. We wanted to make this available for everybody that needs something like this. So we had 3 main ideas. They're all based around the same concept. You have a laser, and as soon as the beam gets broken, it stops the timer. So that's the basic concept. But we have 3 main ways we could do this. So the laser and receptor on opposite sides of the track. That is what that's the original design. That's what most people do. So it's just a laser on one side, receptor on the other. The problem with that is either you have to have a wireless signal traveling back across to let the system know that it has been broken, or you have to have a big wire dangling or on the ground. So that's not too good. So our second idea was the laser and receptor would be on the same side of the track and a retroreflector would be on the other side. So retroreflector is basically a bunch of reflective, usually they're tiny glass beads. That's what they use in road signs, stuff like that, so that the light, no matter which angle it hits at, it always bounces straight back. The problem with that is retroreflectors aren't very accurate in the scheme of things. For instance, if a road sign was a true retroreflector, you would not see the road sign at all because the light would bounce directly from your headlights to the road sign and back to your headlights, and you wouldn't see it. So it's hard to get a perfect retroreflector. So that's one of the problems with that idea. Number 3 was we used an LED. So a laser is a very, very precise type of light. An LED or some other, just an array of lights we could use to also do the retroreflector, but it would be a broader span of where you can put the receptor and where it would still get signal.
This is our design matrix. Simple design matrix to determine which ideas we wanted to pursue. We chose the second one, correct?
Yep.
Second one, because number 2 and 3 were very, very similar. The main difference is one was the LED and one was the laser. And we wanted to go with the laser because we knew that it would work. And if we would have had more time, we could have experimented with an LED, but we knew the laser was strong enough that we wouldn't have an issue with it picking it up.
So we didn't 3D print any parts because most of our parts are electronics. So we didn't have anything to 3D print really, but we did draw up all of these different parts. This is LED. This is our breadboard. That is just a random box, so it fits all the parts, and all of the parts are integrated into it. That's our Arduino, and that is our 7-segment display right there. So these are the most complicated parts. We did not draw wires and resistors and small things like that, just because it's kind of pointless to draw them since they're so small. But these are the parts that actually take up the most space, so that would affect what type of container you put it in.
This is our assembly. So this is just a basic box we just came up with on Inventor that would host all our parts, so it's all contained in one unit. So there's our display, LEDs, laser, Arduino, and breadboard. It all goes into that box if we were to make one, and that way it looks sleek and appealing to the eye.
So this right here is our prototype. It is not in the box because the box is not what's important to us. The company that pursues this idea can put this into whatever type of box they want. It can be self-contained. It doesn't really matter. So they can make that based off of graphics. As you can see, it's pretty small and it can be manipulated into lots of different shapes. So for our prototype, we did not have the proper materials to make the idea we wanted to pursue. We did not have a strong enough retroreflector. We did test around with some retroreflective tape that we picked up, but it was not accurate enough for the laser. So you can see that right here we have the laser in ours, and here is the retroreflector. So we have this long tube so that there's no other light going into the receptor on this end. And it also kind of bounces the light in so it all goes to the end. So we ended up going with design number 1 for our prototype, but if we were to pursue this more, we would have went with design number 2. So this can really go in any type of container. Like we said, the problem with this design is you have all this wire, and realistically this section right here would be your track. So since this is a prototype, we can't really run through here. You can see my hand lights up as it's hitting the laser, so there is a laser in there. And we're going to do a quick test here. So we have this button, and then Adam, if you want to hold up the display so people can see that. So when I press the button, we have a red LED, and then it counts down yellow, 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 green. And as soon as the green LED turns off, it'll start at 3 seconds, because that is how long it takes for the green LED to turn off. And then Adam, I want you to just walk around a little bit. So we're timing Adam walking around the room, because that's a very valuable thing. We need to time.
Fast right here.
And then as soon as he's done, he will one through right there, and it'll stop the timer at exactly what it is. So once again, we press the button, it'll give a countdown, red, yellow, 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 green.
3 seconds.
3 seconds, and it'll start the timer at 3 seconds. So you don't lose any time. It's just a weird programming bug type of thing. And then as soon as you put your hand in there, or as soon as you run through it, ride your bike through it, as soon as the turtle walks in front of it, it doesn't matter what you're doing. As soon as something breaks that beam, it'll stop, and it'll stay like that. Now, the cool thing about this is our website. So we created just a small basic website to do this. So this is just a small capability of what this can accomplish. So with our system, we just have it. It's run by an app on your phone, so you can either start it from the button. This is how the prototype has worked, but you can start it with an app on your phone. It'll start, and then it'll do the countdown sequence, and it will wait a couple of seconds to register. It doesn't. There are settings on the website so that you can change if you want a delay in the laser. For instance, if you're starting behind the laser, you don't want it to cut the time as you pass through the laser. You might want to give it a 10-second delay or something so you have time to pass by the laser. So that's all settings that we have on our website. Another thing with this is you can export this data wherever you want. If you want to program it to get it onto your own database so you can make graphs and whatever, good, go for it. Our prototype is very customizable. Along with, you can add lights or whatever else you want. You can also do the software side of things. So this is a basic just chart of times, best times, whatever. You can do all sorts of stuff. You can make categories. It doesn't really matter. The possibilities are almost limitless with this.
So our closing, our product used for any sort of lap timing, the prototype here, it's just what we have time for. We could make it bigger, you know, if we decide to go that route. And it cuts costs dramatically. Like you said, there was one for $5,000, there was one for just over $1,000. This is less than $50 in material. So it is, our big thing is it's not costly for people. And here's a quote by Bobby. In racing, I wanted to be a winner, and to be a winner, you have to be willing to take or roll the dice. And we hope you're willing to roll the dice with our product. Any questions?
Yeah.
So, the prototype that you have tracks for one lap. Are you guys planning on having it able to, you know, track multiple laps or
Correct.
count the
So
laps
that
that
is-
you take?
In the website, there is a bunch of options. When you're setting it up, you choose the person, so you can put a new user, so you can later search by that user to find all your times. You put, we had it set up, at my house, we have 2 different tracks. We have a dirt track and a grass track, they're different lengths. So we had a dirt track records and a grass track record, so you could select that. So there's multiple options for different categories. And you can say you wanna do 1 lap, 2 laps, 3 laps, 5 laps, whatever you wanna do, and it will only register on the 17th lap if you choose to. So it's very customizable on the website.
Corbin, you got a question? Looks like one's boiling. Go.
Yeah, Travis.
How'd you guys make the website?
I did it, HTML, CSS, Chandler hosted it, my brother, he's a computer science major, so he had a spare server, hosted it on there. This is, not this one, my other Arduino is Wi-Fi capable, so we had that down by the track, and it would automatically, download the request for the timer and upload the results. Yeah.
If you're trying to use it in an area without internet connection, have you guys thought about having the having like a program built into the device and then have it like Bluetooth connect?
We could pursue that route. We have just been doing Wi-Fi. It is simpler, and I don't have an Arduino with Bluetooth. But if we were to pursue that route, that is something we could definitely do. Same type of thing. In that case, it would be an app instead of a website. But yes, we could totally do that.
So is it storing your laps locally right there?
It
or
is not.
Okay.
It is just directly uploading it to the website. All this does is takes the time and puts it on the website.
Where do you see this being used?
Any racing sport. So it can be mostly for personal use, I'd say. Or
Training.
yes, training would be a big thing. For running or something like that. This is very accurate. Back on the website, you can see we got down to the millisecond for timing. So you can go pretty hard. And or if you're trying to beat one of your friends on the drag race, you can say, oh, I got 0.001 seconds better than you. So this is very for a personal standard, and that's why we made it so customizable, because not everybody's racing the same stuff. And we also made it very cheap and cost effective.
So for example, like Isaac's track, the track itself is no longer from him to me, so it means you can't fit like 2 quads on there. You could do 2 dirt bikes, but it's getting pretty close and it could be unsafe. So this is where it's, like you said, a personal use, so it's for when one guy's racing on a track and competing to beat other people. So you can fit a snowmobile through there, you can fit anything you want that touches the ground so it trips the laser.
Yeah.
Have you ever thought about making it float for boat races or jet ski races?
Well, we haven't, but I'm sure that since this is totally customizable by the customer can definitely do something like that.
Okay.
Do you see the need for building a stand for that as well?
So we have not. Since we were trying to pursue the retroreflective idea, the goal would be that it is in the box. So our box right here, all this would do is set on the ground. The nice thing about the retroreflector, you set this on the ground somewhere,
It'll find it.
and it'll find the retroreflector. It doesn't matter if you place it at a 45-degree angle, it'll bounce straight back. That's why we wanted to do the retroreflective idea, because then this could truly be on one spot. The problem with this idea number 1 is you have to have the laser kind of separate from everything else, because it has to be, you can't bump it at all. So that's why I kind of made this contraption for the prototype, and that's why it's so small. But that is, if the customer wanted to put it on anything, you can just plop it on a table, put the retroreflector over there somewhere, and you can go for it. Yeah.
With this design, have you thought about, instead of having all the wires, make like Bluetooth receptors on each, the laser and the receptor?
So the problem with that is, time. Bluetooth takes time. So, and the problem is it's not always the same amount of time. So depending on distance and other factors, it would be hard unless we had the Arduino on the receptor end and one on the laser end to kind of balance that out. So this is just the simplest thing. Bluetooth, you saw in the like $5,000 one and the $1,000 one, they were wireless.
Yep.
That's why. The Bluetooth thing would knock it up thousands of
So that's what you lose when you go with cost effective. You don't have as nice of parts in there, but it still does the same.
So we have a very low basis for this prototype. It's cheap, but you can do so much with it. If the customer would want to add Bluetooth, they could sure do that because it is very customizable. But the problem is we lose the capability since we went so cheaply to add anything like that on. Yeah, great.
Would glossy paint or metallic paint on a vehicle affect the system at all?
Not that I have tested. So, the good thing is, on most vehicles, like let's say you're running a car, the front of a car is curved, so it should bounce it directly back. The receptor is very, very small, and that's why any little variation, and imagine if it's if the laser is where I'm at and the receptor is where I'm at, the receptor is maybe a centimeter in diameter, any little variation on that would bounce, it'll go askew a little bit, and so it should be a problem. This is why we've also made the long tube. We've also dealt with problems of like, if you're in bright sunlight and you had the receptor right out in the open, it wouldn't work. So that's why we kind of had the long tube there.
All right.